There's a detail here that I neglected to mention. It occurred to me while I was out working a little bit. Here, if a straight line falling across two straight lines makes internal angles on the same side less than two right angles, then the two other straight lines being produced to infinity meet at that side. Okay, so this is the Greek. This is what Euclid actually wrote. This is in the curved space examples that are supposedly counterexamples to this. There is only ever exactly one line segment falling across your two allegedly parallel lines that satisfies this angle measure. If you change that line at all, it doesn't work. There's literally just one. Okay? And that's not what this means. This is a generalized, like, you should be able to drop any line segment on there. All possible line segments that you drop on there should behave this way, which is another reason that the curved space thing doesn't work. Because, so say you were working on a circle, right? Or we're working on a sphere, right? So we've got these great circles. And so you drop in... right, so take like lines of longitude and the equator. Okay. Every line of longitude that the equator intersects with, you're going to have 90 degrees, right? So two lines of longitude at the equator, it looks like the equator is defining these as parallel lines. But as soon as you move off the equator, north or south, but you take a circle that is like another line of latitude, it's not going to work. The equator is the only one that works. Literally the only one. And if you try to tilt it, it won't work either. So, yeah, this is a problem. This is a problem, right? So if you're up at like the Tropic of Cancer, now when you intersect two lines of longitude, you're not going to it's not going to satisfy the angle sum, right? So there is a line that does this, but that's not what it means. It means that any random line, any given line, it's like when you say a cat has four legs. We're not talking about a specific cat, and we're not saying that there's only one cat in the world that has four legs. What we mean is cats in general have four legs. Cats, as a category, have four legs. So these lines crossing your two potentially parallel lines, that line segment that's crossing them, it's a category of all possible ones. And that is missed in translations, or it's misunderstood. And yeah. So like if you are doing work with this, one way that this is very, very useful is you can take a measure, right? You can just pull an angle off of one of your potential lines. So, drop in, say you want to make two parallel lines, okay? So you drop in one of them, and then you want to get a parallel one. So what you can do is you can just take some random angle and length and combine those, pull it off of that line, put a point at the end of it, move that somewhere else, put a point at the end of that, and then connect those 2 points, and now you have two parallel lines. That's what this means. Every single possible straight line falling across your two lines should make internal angles on the same side less than two right angles, and or equal to two right angles. I was just reading it. Equal to two right angles, right? So you're right. However the fuck you want to say that. Yeah, that's a problem. That's a problem. That your curved space analogies never even touch. There's only, in the curved space ones, there's only ever one possible intersecting line that works. And this is also never mentioned. Like, it should be the category of all possible intersecting lines. The category of all possible intersecting lines should give you the same behavior. All of them. And in curve space, that's not what happens at all.